Welcome to the next lecture on special distribution functions that we actually use practically. So coming to the special distributions that exist in probability or discrete as well as continuous distributions. So only few we are going to see here. So coming to the discrete distributions, we have Bernoulli, binomial distribution and Poisson's distribution. And coming to the continuous distributions, we have uniform distribution and Gaussian distribution. So in this lecture, we'll deal with the discrete distribution, and in the next lecture, we'll complete continuous distribution functions. So coming to the discrete distributions, the first one is Bernoulli distribution. I think all of you have heard the term Bernoulli trails. So Bernoulli trail is nothing but having only two events. So in that two events, it is either a 1 or a 0. So you can say that a random variable x is said to be a Bernoulli random variable with parameter p if its probability mass function is given by. See, we are using the term probability mass function because it's a discrete density function. So for discrete we use a density function as probability mass function. For continuous we'll pronounce it as probability density function. So it has a parameter called p. So here I just told you here Bernoulli is taking values 0 and 1. So what does it mean? Either a false event or a true event, or you can even interpret as this is success and this is failure. So only two events, either a 1 or a 0. So for that, what is its mass function? Px of k is equal to probability of x taking a particular value k is equal to Bernoulli distribution has this as its statistical representation, p power k multiplied by 1 minus p whole power 1 minus k. So when you substitute k is equal to 0, what is its value? 1 minus p power 1, p power 0, so which is equal to 1 minus p. Similarly, when k is equal to 1, this is 0, so you have p power 1, so it is only p. So if it is p when k is equal to 1, and when k is equal to 0, it is 1 minus p. That means you have only two events. So if you represent that here, Bernoulli, the probability mass function, at 0 it is taking a value of 1 minus p, and at 1 it is taking a value of p. So this is probability mass function. And coming to the distribution function, you can see in the distribution function, this is actually the fundamental notation to represent the distribution function. Always use a flower bracket and write it as a function. So when x less than 0, so when x is less than 0, it is what? It is 0. So it is only 0. So it is taking only 1. Next, when x is less than or equal to 1. So what does it mean? 0. X is greater than or equal to, see, this is only less than 0. Greater than or equal to 0, and which is less than 1. What is its value? It is nothing but k is equal to 0. So which is equal to 1 minus p. And x greater than or equal to 1, what does it mean? X greater than or equal to 1 means it is also equal to 1. So that means x is at probability of x is equal to 0 plus probability of x is equal to 1. So what does it mean? 1 minus p plus p, which is equal to 1. So this is nothing but its distribution function. So how will you plot the distribution function? Distribution function, it's a step function holding a constant value at x is equal to 0, which is 1 minus p. And at x is equal to 1, it is equal to 1. So it's a staircase approximation function. The maximum value is equal to 1. So always when you write the distribution function, the maximum value, the last value will be definitely equal to 1, because the sum of all the previous functions, because it is x less than or equal to x, cumulative, when you add it up, you will get it as 1. The maximum value is always equal to 1. So Bernoulli distribution means it is a Bernoulli trail taking only two values. So its probability mass function is p power k into 1 minus p whole power k. So once you remember that, it is easier to write its distribution function. So in the Bernoulli, it is only two events that do occur. Whereas in binomial, in maths also we have seen a binomial distribution. So coming to binomial distribution, when you increase the Bernoulli, when you conduct the Bernoulli trail n times, that means if you repeat the experiment n times, then it gives rise to binomial distribution. So any random variable x is called as binomial random variable with two parameters. Bernoulli, you have only one parameter p, whereas here also you have a success and failure as p, but you have n times this particular experiment is repeated. So that's why the number of parameters are n comma k. If its probability mass function is given by So Px of k, which is equal to P of x is equal to k, is equal to NCk P power k 1 minus P whole power n minus k. So in Bernoulli, if you remember, it is P power k 1 minus P whole power 1 minus k, because n is only one time the experiment is conducted. Whereas n is here, k will take a value from 0, 1, 2 and so on n. So that is Px of k, NCk P power k 1 minus P whole power n minus k. But P lies between 0 to 1. And you know what is NCk? It is n factorial by k factorial n minus k factorial. So this is already we know it, which is known as a binomial coefficient. So this is actually, NCk is actually called as a binomial coefficient. And the corresponding cumulative distribution function of x will be equal to, this is Px of k. Its distribution function will be equal to k is equal to 0 to n, NCk P power k 1 minus P whole power n minus k. So what does it mean? You have to do the summation of this particular event till n. So that's why you are just introducing another term called as summation. So summation NCk P power k 1 minus P whole power n minus k will give you the distribution function. So how will you represent this? For example, if you take n is equal to 9, P is equal to Q is equal to 1 by 2. So this density function will look like this. So it is increasing and then decreasing. You can calculate for each value. Substitute P as 1 by 2. So 1 by 2 into 1 minus 1 by 2 whole power n minus k. So n is 9. So 9 minus 0. So 9 minus 0, 9 minus 1, like that you repeat it to calculate its values. Same thing, you can plot its distribution. Always the distribution function is staircase approximation function. So ranging all the values. So coming to the next discrete distribution, which is actually called as Poisson's distribution. So what is Poisson's distribution? So Poisson's distribution has a probability mass function given as Px of k is equal to e power minus lambda power k by k factorial. K is equal to 0, 1 and so on infinity. So it is an exponential function. So that's why it is till infinity. E power minus infinity also, lambda power k by k factorial. And the corresponding distribution function will be always a sigma. E power minus lambda is a constant. Sigma k is equal to 0 to n. So what is its parameter here? The Poisson's distribution has a parameter lambda which is always greater than 0. So e power minus lambda is nothing but its parameter, lambda per k by k factorial. So this is Poisson's distribution. So where do we use these distributions practically? So all these discrete distributions like Bernoulli, when you have only two outcomes, either success or failure, then we'll go for Bernoulli. If suppose the same experiment is repeated n trials and all are independent Bernoulli trials, then we'll go for binomial distribution. Similarly, in the Poisson's distribution is actually mainly used when you want to calculate the delay. When you go for any protocols in internet networking protocols also, it uses Poisson's distribution to estimate the time of next packet to be transmitted, and approximation to binomial random variable when n is large and p is small. So the same binomial distribution, it is having n and p as two parameters. If suppose n is higher, larger, then NCk calculation of binomial has a limit. So that's why we go for Poisson's distribution. So coming to its parameters, Bernoulli has two parameters, 1 or 0, whereas binomial has two parameters, 1 and p. Coming to Poisson's distribution, you have two parameters, n and p. Okay, so with this we'll end this lecture. Thank you.